As a programmer, you tend to want to solve a problem once and then reuse your solution in other places. This is what we think of as abstraction. So you might write a simple little algorithm, put it in a function, and want to be able to reuse that function in other files or potentially even other projects. Well, in Python, the ability to import modules from one place to another and the names and the definitions in those modules around to other parts of your project is a fundamental concept to understand as you're becoming a Python programmer. Similar concepts exist in other languages as well, but we'll have slightly different mechanics in how it all comes together. Let's talk about how this works in Python, and I'll ask you to join me in VS Code. So in VS Code, I'm going to open up my File Explorer, and I've got a few directories set up in this project. This is just a Python project where we've got some source directories. One of them is named lessons, and we think of this directory as a Python package. A Python package is going to contain many modules, and modules are just Python files. All right. So let's go ahead and set up a new module named helpers.py. In reality, modules and packages are more nuanced than files and directories respectively, but for our purposes, we can think of them as one and the same for the time being. So this helpers module is going to define a powerful function used elsewhere. Right? So what is our powerful function going to be? Well, we're going to be a little bit silly here and say that powerful is a function that just raises one number to the power of the other. And of course, that's not a very powerful function. We shouldn't even be writing a function for this. There's a built-in operator to do that. But this video is really about how do we import functions. So that's why we're going to keep this particular function definition very simple. So this is a function that you give it two floats, x and n, and the documentation here is return or evaluate to raise x to the power of n. And of course, we're just going to return x raised to the power of n, right? So a very simple little module here, with a very simple function in it. The key question is, how can we use this function and call it from some other module? Well, let's set up another module that would allow us to figure that out. So once again, in my lessons package directory, I'm going to set up a new file, and let's name this imports.py. Okay. So in imports.py, we're going to say, okay, this is a file that is examples of importing other modules. All right. So what we'd like to do is import from some other place a specific name. What do I mean by that? Well, I'm actually going to go split screen here. So I'm going to drag this imports.py tab over to the left and drop it such that the imports.py module we're working on is over here on the left-hand side, and helpers.py that we had just previously set up is on the right-hand side. If you want to do that, you can. You don't have to. So the key thing to recognize here is we're trying to import something from the lessons package. Right? So from lessons, right, that's the directory name that we set this module up in. What are we importing from lessons? Well, we're importing a module named helpers. And when we're thinking about module names, we don't use the .py. The .py is just to say this is a special kind of file. But when we're thinking about modules in Python, we're not going to have that kind of extension. We're just going to say, okay, from lessons, import helpers. Great. All right. And now what we can do is actually make use of this module by calling it. So let's say print helpers.powerful. And then what are we going to give as our parameters to powerful? Let's say 2 raised to the power of 4. Okay. So we imported the name helpers. And now from this line forward, helpers is going to refer to the definitions or the names that were defined at the global scope of helpers.py. So when we print helpers.powerful, we're going to say, okay, go look up in this module that we imported the powerful name, and that's going to resolve to this function definition, and go call that function. So if we wanted to test out whether or not this actually works, we could try in our terminal running Python, and we're using Python 3, a very modern Python release, 3.9, Python -m lesson.imports. Oops, and I forgot the S in lesson, so lessons.imports, and we see 16, right? So I can rerun that again. Lessons.imports, lessons is the package name, imports is the module name, and we see that 16 is evaluated. So we've successfully convinced ourselves, hey, this works. Well, what's actually going on behind the scenes here? Before we demonstrate exactly what's going on, I want to add two peculiar print statements to this example. Right? So the first print statement I want to add is print _name. Okay. And I'm going to add that just above the print helpers.powerful. Okay, so if I run this, we see that the name variable must be one that's set up to be a global variable, and it's special in Python. And you know it's special because of these double underscores. Anywhere you see a variable name surrounded by double underscores, you know that Python, the programming language, has some special meaning associated with this. This is a double underscore name or a dunderscored name. So we should know that Python uses this for its own purposes, and we have to adhere to its uses of it. And for whatever reason, this name is main. Okay. Now I want to try adding that same print statement anywhere in this file. So I'm going to add it on just below my, actually, let's add it at the very end for now. So print _name. And we're going to do this from helpers.py. And there will be some motivation for this. We'll have a reason for this. We're trying to understand what this special variable is. And it has very important context when we're talking about importing various things. So notice when we said python-m and we ran this lessons.import. So we ran this module and lessons.helpers was printed out first. And that wasn't being printed before. So that must be coming from here. And if we wanted to convince ourselves it was coming from here, we could do something like print fstring and then helpers.py. And then in a template variable, we could use this name, right? And so I could add the same thing here. So print fstring imports.py name. All right. So I'm going to clear my output here and try this one more time. We're going to try and get to the bottom of what's actually going on when we import a module. So notice this print statement is being evaluated before this print statement. Okay, well that tells us something kind of interesting, right? That means that when this line 3 is evaluated, Python must be fully evaluating this entire helpers.py because this print statement is being evaluated. And it's telling us that name, this special variable, in this imported module is named lessons.helpers. There is assigned a string lessons.helpers. But when we print the name variable in the globals frame of imports.py, we see that it's the special __ main. And then finally, we see 16 printed out. Now, something else kind of peculiar happens if we tried to run lessons.helpers directly. Right? So let's try that. So what happens? Python-m lessons.helpers directly. And I want you to pause and think about, what do you expect this program to do? If we fully ignore imports.py, this is the only program we're running because that's the module we're running. We see helpers.py is followed by, and then the name here is __ main. That's not what it was before. Previously, when we ran imports.py, this printed out helpers.py, and then the name variable was assigned lessons.helpers. So there's some peculiar behavior here that we'll try and understand through running a memory diagram. But what you can hopefully start to appreciate is whatever module you run from the command line, in its globals frame, the special variable name is going to be assigned __ main. But when you import a module, so let's reevaluate this one more time. So I'm going to run my imports module. When we imported helpers.py, any module that gets imported within that module, the name variable in its globals frame is going to be the package name .module name. Okay, so that's a lot of details. Let's break this down step by step in what's happening starting from evaluating imports.py. So in my memory diagram, I'm going to set up a globals frame, and I'm going to set it up specifically for my imports.py file. So imports.py, right? And globals. So in globals, we have seen that, okay, we're running this particular module as a program. And so Python is going to bind the special variable name to be the string main. All right? And this is happening behind the scenes and automatically on our behalf, just by virtue of saying, hey, this is the file we're running as a program, right? That is happening before our program even loads. And then on line 3, we reach this import statement. And we're setting up the name helpers in our global space. Right? So when we import something, whatever we import is going to be added to the scope that we're currently in. And currently we're in globals. So helpers is being established as a name in imports.py's globals. But what is it bound to? What do we do next? Well, what happens next is Python says, okay, let's go evaluate this other module. And it's going to have its own separate globals frame, right? So this is going to be helpers.py. And it's going to have its own globals frame. And its name is going to be slightly different, right? So we just talked about how when you import a function and we're evaluating, or sorry, when you import a module and you're evaluating a module as an import, this would be the name of the module, which is lessons.helpers. We'll talk about why this is important in just a moment and why this is why this makes sense and why Python made this decision. Okay, so that name is established. And then what happens? Well, we see that there's this function definition named powerful. So let's add that definition. So we add the name powerful to our globals frame. And this is going to be bound to, and I'm just going to separate this out. So I don't have much space over here in my heap, but this will be the function defined on lines 4 through 6, right? All right, so this is my heap, or this is where the definitions of functions and also lists and other things are stored. So powerful is this function that's defined on this heap on lines 4 through 6, okay? Then we reach this print statement, right? And helpers.py, this gets printed out. And if we were recording output, I'm going to skip through that. We would record that. And then once this module completes, once we finish line 9, what do? Well, we go back. We're done with this import. And now what happens is helpers. So I'm going to surround everything in this globals frame, right? So helpers is going to be bound to the names in the globals frame of the module we just imported, right? So helpers now has access to, the powerful function because it's a reference to everything that was left in globals frame after that module evaluated. That's pretty cool. From there, what we did was we printed out, well, what is name? And actually, before we get there, let's imagine, so when this print statement evaluates, notice we were in the context. Our local scope was globals and helpers.py. So that's why lessons.helpers printed, because we were evaluating in this context where name was the name of the module. But when line 6 evaluates, we're back over in the globals frame of imports.py and name is established to be main because this was the module we were running as the Python program, right? And then we can see, well, we're calling helpers.powerful. Well, helpers, and then when we see a dot, we're following our reference to, okay, yeah, do we have a name powerful? Yeah, there's a function named powerful defined in the globals frame of this module that we loaded. So it's good to go. We can call that function from there. So that's how this comes together. Now you're probably wondering, well, what's all this about? Why do we have this special variable name? You'll notice that there's two different scenarios here. We either have a module that we run directly as a program from the command line, like we've seen here, python-m lessons.imports, or we're importing. And we tend to just, when we import, we kind of just want to make use of the definitions in some file. We don't want another program to run. So we can get the best of both worlds thanks to this special name variable and an idiom in Python for how we would establish what should happen when we run a program when we run a module as a program versus when we import it for its definitions. So what we'll commonly see in Python is a special if statement. So if the name variable is equal to main, then what we might do is, we could say print helpers.py and then the name. We could also, print powerful of, say, 2 to the 10th. Otherwise, we wouldn't do anything typically, but let's add an else here just for demo purposes. Otherwise, we might print this module was imported. Okay, and actually, let's change this to be helpers.py module was imported. Okay, so now what we can say is if we tried running lessons.imports, what we're going to see is, notice helpers.py module was imported because name was assigned lessons.helpers when we import. This is not going to be true, so we would go to the else and we print out helpers.py was imported. However, if we tried running Python and the module lessons.helpers. So now we're going to say, okay, let's ignore imports.py. Let's just try running this particular module as a program. Notice that name is main because this is the same. This is the module we're running in our command line command here, and these two lines evaluate. Right. So this idiom exists such that we get the best of both worlds. We can now both run this helpers module as a program, and these lines will evaluate. We would probably set up a main function like you've maybe seen in other contexts and call that main function from here. Otherwise, typically we wouldn't do anything. Like I would probably just go ahead and comment these lines out and say, typically you would not have an else here. Right? And maybe we'll make a quick comment to say idiomatic Python having a main function. So if we wanted to carry out this idiom a little bit further, and in this helpers.py file, like truly embrace the idiom of Python where we have a main function, we could declare another function in this module named main. And we could say it's a procedure, it doesn't have any return value. And we could give this a comment of entry point of our program. And maybe here what we would do is copy these or cut these two lines and move them up and change what we do when name is main to be call this particular function. All right. So let me get this terminal out of the way. So this idiom, typically, you'll see it look something like this, where if this module was run directly from the command line, and we know that that the name variable will be assigned to main when that happens, we will call the main function, and this function will be evaluated. Otherwise, if we import this module from somewhere else, main won't get called. Okay, so we can demonstrate this one more time, and let me close my pre-existing terminals there. And so I can run python-m lessons.helpers. And notice that this main function was evaluated thanks to this idiom. However, when we ran imports, so lessons.imports, when we ran this module, notice we imported this whole module. So the main function definition actually was loaded, and we could call main from imports.py if we wanted, and I'll show you that in just a second. But then we didn't actually call the main function from over here. So we skipped over that part. And that's typically what you want to have happen when you're importing definitions from one module to another. If we wanted to prove to ourselves that there's nothing special about this main function, we could call it, let's say helpers.main here. And we would see that the output would be pretty similar, where we have 16 is this first line, and then helpers.main is what had these print statements being called out and evaluated. Right? But that's a little bit strange to do. Typically, you wouldn't call the main function defined in another module like that, so I'm going to take that part of the example out. Two other things I should mention are that there are a few other kinds of imports you can do in Python. So first, let's add an example of aliasing an import. Right? So we could say from lessons import helpers as HP, right? And what we're doing here when we use this as keyword is we're saying, hey, rather than using the name helpers, use this alias. So now we can say HP dot powerful 2, 4, or 5, right? And let's print that result. Okay. And while I added this import here, I forgot a classical constraint of Python imports, which you always have to have them at the top of your Python modules. So let's do that before I actually added this print statement. So we can add this here. So all of your imports do have to happen at the top of your file. And this is a very nice convention that Python enforces on us, such that we know what the names that are bound from other files are going to have, where their meanings are coming from. It turns out you can also import in other scopes. So here we're importing at the global scope. You can import within a function definition, and that name will only have meaning in the function definition's body. But it's much more common to import globally at the module level. Okay, so this example is using the alias HP, same as helpers, right? So if we wanted to convince ourselves that this would work, I could run this file one more time and notice that we printed 2 to the 4th, and that was 16. 2 to the 5th is 32. And the last example I want to show you is, well, what if we wanted to just import a function directly? Now, typically, best practice is import a module and then use that module name dot and then function name to access the functions within it. It's very common to alias in this way, and you'll see this in lots of examples of libraries you might import from around the internet. But sometimes it's really handy to be able to add the name of some function in some module directly to the globals frame of your import of where you're importing. So let's import a function definition. So from lessons dot helpers. So notice we're saying from this particular module, what we're going to import is the name, say, powerful. Okay. And this would, we could now then, because we imported the name powerful from this module, we can now use the powerful function directly if we wanted. So print powerful, and then say 2 to the 6th, right? So expect that to be 64. And what do you know? It would be strange to do all three of these things in the same file like we're doing here. But for the purposes of demonstrating the different ways you can import things, this is a good example. So you're probably wondering, well, what would this look like in memory? And let's bring that home. So if we had done all of this, we made 2 changes here. So one change that we should reflect is that in helpers.py, we added this main function definition. So in my diagram here, I'm going to add, a main function definition to its globals. And I'm not going to worry about the line numbers. We'll just say that's the function definition, and we know that that's the case. All right. So what happened when we imported the helpers module? Python went and loaded this module. Everything that was left in its globals frame is what we have access to through the helpers import here. All right. Now, when we aliased, when we did this style of import, because we had previously imported this module before, Python doesn't go and import it again. There are ways of forcing Python to do that, but typically you only want to load a module once because you care about what's in its globals frame. And then when you import certain things from it in other places in your program, you don't really want it to have to go re-import each time. So the first time we import something from a module, that module loads, its global names are available to us. And then the second time we import something, we just reuse that. Okay? So in this case, what we wound up doing is saying, oh, we've already loaded this helpers module. So now the name HP, oops, let me be consistent with my color here. The name HP is going to be bound to that globals frame as well. That's pretty cool. And for that reason, we're able to say, hp.powerful. We get to also say hp.main. And that would allow us to have access to the main function. And then lastly, this powerful function, when we imported it directly, what that would look like in our diagram is we would say, okay, well, we're importing the name powerful. And what is it bound to? Well, it's going to be bound actually directly to this entire function definition. And so we can use it directly. All right. The things that you can define in globals, such as global variables or constants, we could also access in this way. And let me just close out this video with an example of that. So let's say we had a constant that was something such as the answer, and maybe it's an int and it's the value 42, right? Well, we could also print, and let's do this up here with this top example. So we could print helpers.theAnswer. And we should see that 42 gets printed out. So I'm going to save both of my files. Remember, when you're working with multiple files in VS Code, be sure to save it. So 2 to the 4th was 16, and then we printed out the answer, which was this constant that we set up in helpers.py. And because this was declared at the global level in this module, when we went and evaluated that module, what would have happened in memory is there would have been a constant over here, the answer, to life, the universe, and everything, is 42, right? And so because we declared that as a global name in our helpers module, over from our imports module, we could access it just the same. You could also import it like we did powerful. Like if you wanted to import that name directly, we could have also said, import a constant or variable. And I might make this specifically a global constant or variable. So from lessons.helpers import the answer, right? And if we had done that, we could have used this variable directly. And I could just give an example of that. Use an imported constant directly, print the answer, and we would see 42 printed as the last entry in our output. And again, this is going to have an influence on the globals frame of our imports.py file or our imports.py stack, right? Because whenever you import something, you're adding that name to the scope that you're importing it into. So that would have had the effect of saying, okay, the answer in the globals frame here is 42, right? So we imported that value, and because that was an integer, we just copied it over. Now, for the purposes of our course, we're not going to be diagramming multi-file diagrams in memory. So you don't need to concern yourself with being able to reproduce a diagram like this. But this intuition of, okay, well, when we import something from another module, the first time we do that, that module is going to fully evaluate, and whatever is left in its globals frame is what we're going to be able to import into the other module. That's the key idea behind the importing system in Python, and brings us to a good stopping point on this concept. As we write larger programs, it helps to break the functionality down so that related functions are stored in the same file, and you import those functions or other concepts such as classes and constants and variables into your other modules. That special variable name is going to change whether or not you're running a module as a program or importing a module somewhere else. And the way it changes, and the reason for the idiom that you'll see very commonly in Python programs, is so that you can write a module that gets the best of both worlds. You can run it as a program, and you can also enable other packages and modules to import functionality from yours without your program running. Great work on this video.